Hello everyone, this is Amika Mahajan. Welcome to my channel. This video, I am going to discuss Coulomb law in vector form. You know, if we have 2-point charges separated by distance r, then this is force acting between them given by Coulomb law, 1 by 4 pi epsilon naught q1 q2 magnitude upon r square. Very important. Now I will represent it in vector form. Why? Because force is a vector, so it is better to write Coulomb law in vector notation. Very important topic. Please try to understand this. This is the situation where two charges q1, q2 are separated by distance r. Then this is the magnitude of the force acting between them given by Coulomb law. F equal to 1 by 4 pi epsilon naught q1, q2 magnitude upon r square. Now I have to represent this in vector form. This force is acting along line joining these two charges q1 and q2. So this line is represented by position vector r. So if I take this direction, I have to find unit vector along this line. This will be r cap. R cap is the unit vector of r vector, which can be represented as r vector upon magnitude of r, already done in 11th class. So if I multiply this magnitude of the force with r cap, I get F vector. That means in vector notation, this force will be 1 by 4 pi epsilon naught q1, q2 magnitude upon r square. This magnitude has to be multiplied by r cap. Why r cap? Because this force is acting along this line. So I have to take unit vector. Unit vector describes the direction in which we are talking about. We are talking about this direction. So r cap will be multiplying this magnitude. This is vector notation of Coulomb law. So this r cap is further written as r vector upon r. So this F will be 1 by 4 pi epsilon naught q1 q2 magnitude upon r square. In place of r cap, I can write r vector upon r. When I solve it further, it will be 1 by 4 pi epsilon naught q1 q2 magnitude upon this r square, and r will make r cube multiplied by r vector. This is another form to represent Coulomb law in vectors. So there are two ways. One, multiply this F with r cap. And second, multiply this magnitude with r vector. Now what is the difference between these two? In this case, denominator is having r square. In this case, denominator is having r cube. So please keep in mind, if you are representing in r cap, then in denominator it will be r square. If you are represented as r vector, then in denominator it will be r cube. These are two important forms which are vector forms. Now, this was the situation when charges were like this. If I take this kind of situation in which q1 charge is present at origin of this coordinate axis, and q2 is the charge at point P whose position vector is represented by r. Again, now the force will act along this line. So I will take unit vector of r vector. It will be r cap. So if I multiply this magnitude with r cap, what I get? Again, I get vector form, which I obtained in previous case also. And you know, this r cap can be written as r vector upon magnitude of r. So I can write it as 1 by 4 pi epsilon naught q1 q2 magnitude upon r square. This r cap can be written as r vector upon r. These are the magnitudes. So 1 by 4 pi epsilon naught q1 q2 upon r cube. And in the numerator it will be r vector. So what I find? Again, same form I am getting, whether the charge is present like this or it is present like this. The main thing is that first charge q1 is present at origin. Only then this form is written. If this charge q1 shifts to some point here, then what will be the force? Will be done in next video. Thanks for watching this video. Like, share, subscribe my channel.